we are going to study in deep of what is CORBA ORB, Object Request Broker. So we are going to study in depth of communication, how the ORB is communicating through network. So that is called as inter-ORB communication. And you know what is ORB, Object Request Broker? That is the heart of CORBA architecture. And this ORB is actually handling all the requests and responses, and all the requests and responses will be processed in ORB for both end, for the client end and on the server end. There are ORBs. That is the reason why we called ORB as a heart of CORBA architecture. So let's see how ORB is running in internet application or distributed application in CORBA, and what are the facilities it uses, and how this can be implemented in program. First, let us see the introduction of inter-ORB communication, because ORB is meant for communication. So let's see the inter-ORB communication first. The inter-ORB communication protocol that can transmit object requests between various ORBs running on the network. So as you know, CORBA is used for creating distributed applications, and it is platform independent. So here we need a protocol to transmit the request and responses from client to server, and as well as from server to client. So here we are using a protocol called as inter-ORB communication protocol that can transmit objects requests between various ORBs running on the network. We know that there are millions of computer systems or systems are connected in internet. Millions or billions of computer systems are connected in internet, and each computer system is having separate ORBs when a distributed application is concerned. Each ORB is actually using their own protocol to communicate with objects on the network. That protocol is called as inter-ORB communication protocol. So, without protocol, you cannot communicate between the systems, or you cannot have a communication link without a protocol, without an internet protocol. Communication protocol, one of the communication protocol used in CORBA architecture is inter-ORB communication protocol. The protocol are independent of the particular ORB implementations running at either end of the communication link. If you are communicating, you have two links. One is the client link and another one is the server link. When you're passing data from client to server, on the client side, you have a starting point, and on the server side, you have a service point. So between this service point and starting point, you have different protocols, you have inter-ORB communication protocols running behind. So between the protocols are independent of particular ORB implementations, because CORBA architecture is an independent architecture. It is not depends on any particular programming language. It can run on any platform. It can take the help of any programming language to develop. So it is an independent programming language, independent platform. So obviously the protocols running on either side of the communication link also also are independent of particular ORB. So the inter-ORB protocol is responsible for delivering message between two cooperating ORBs. So what is the responsibility of this protocol? It is responsible for delivering messages between two cooperating ORBs. right? So when you are communicating between the systems, I told you have two ends, the starting end and service end. So each side you have a ORB running. So in the ORB protocol is responsible for delivering messages between these two ends, right? Messages between these two ends means messages between two cooperating ORBs. What do you mean cooperating ORBs? When a communication is happening, across a network, the number of ORBs, number of ORBs actually take part in that communication are called as cooperating ORBs. All the ORBs, those who are taking part of particular communication is called as cooperating ORBs. So we can send messages between cooperating ORBs. That is possible. Now, this message might be method request, return types, error messages, etc. This message might be method request, and this might be return types, and there are error messages as well, right? The message can be, it may be a method request. Suppose we are requesting a method, or it may be return types. That means the server is returning some data. Or error messages. Error message means if your request is not successful, or the server is not actually accepting your request because of some error, you will be getting error messages. So that is also a message. Then the Internet Inter-ORB protocol, that is IIOP, is an inter-ORB protocol based on TCP bar IP. So what is the protocol here we are using is the Internet Inter-ORB protocol, IIOP. So IIOP is the protocol we are using in communication. That is an inter-ORB protocol based on TCP bar IP, transmission control protocol by Internet protocol. I'm sorry, there is a disturbance behind. So TCP bar IP is by far the most commonly used network protocol on the internet. So IIOP is the most commonly used CORBA communication protocol. You know that TCP bar IP is the most common protocol used in internet as a transmission control protocol. So same like TCP bar IP, there is a protocol in the family of TCP bar IP called IIOP. IIOP is the most commonly used CORBA communication protocol. This is a very important point. What is the CORBA communication protocol used in internet? The CORBA communication protocol used in internet is IIOP, Internet Inter-ORB protocol. So please keep in your mind, store in your mind. This may be a one mark question. Then creating CORBA objects. So let's see how to create CORBA objects. We have already seen this in that chapter, but again, I told you we are going to see in depth. So creating CORBA objects. So how we are going to create the objects? CORBA objects are created using Java IDL. You know what is IDL? Interface definition language. Right? Interface definition language are used for creating CORBA objects. So by using Java IDL, we are going to create CORBA objects. So this involves doing the following steps. So we are going to follow the different steps to create CORBA objects. First of all, writing an interface in the CORBA interface definition language. We have to create an interface in interface definition language. What is the language? Interface definition language. Ideal is platform independent, so that you can write any code, any programming code inside Ideal, but it should satisfy the communication ends. Communication end means client and server, right? If you have a CPP client and Java client, sorry, Java server, it should match, right? So you have to write code according to that. So Ideal is interface definition language. So first of all, you have to create an you have to create an interface in the ORB interface definition language. That is the first step. Then second step, generating a Java-based interface plus a JavaScript skeleton class using Ideal to Java compiler. So we have a compiler here called as Ideal to Java compiler, like RMIC in RMI. Remote method invocation, we have a compiler called as RMIC. In Java, we have a compiler called as Java-C. In ORB, we have a compiler called as IDL to Java compiler, right? So second step is create base interface, Java step, and skeleton classes. So three classes we are going to create. First is Java base interface, second is Java step, third is skeleton. So these three things we have to create or generate using Ideal to Java compiler, right? So first we have to create an interface. Based on the interface, we are going to generate the base interface, Java step, and skeleton using Ideal to Java compiler. That is the second step. Third step, writing a server-side implementation of the Java interface in Java. So first we created ORB interface, that is called as client. Second, we have created the Java base interface, step and skeleton. You know what is step and skeleton, because without step and skeleton you cannot communicate. So Java step and skeleton. And the third one is we have to implement the server. So how to implement the server? Writing a server-side implementation of the Java interface in Java. Those are the different steps for creating ORB objects. So once you did all these three steps, you have done with ORB object. You have done with creating ORB objects. So let's see what is an ideal primer. Is the time up? No. So let's see what is an ideal primer. It is ideal primer. Interfaces in Ideal are declared much like classes in C++ and thus classes or interfaces in Java. So interfaces in Ideal, I told you Ideal is a separate language. So to create interfaces in Ideal, this is same like classes in C++ and classes or interfaces in Java, right? You know how to create the classes in Java and how to create the interface in Java. Same like the declaration of C++ and classes in Java, we can create interfaces in Ideal. So the major difference between Ideal and Java. So what are the difference between Ideal and Java? Let's see. Ideal is a declaration language. In Ideal, you declare only. You cannot implement any code inside Ideal. You can declare. You cannot derive, right? But in Java, you can declare and derive. That is one difference. And second is the name and type of interface, data members, methods, method parameters, etc. The names and data types for interfaces, data members, methods, method parameters, you have different names for each and everything. So here method implementations are created in the implementation language you choose, in this case Java. After you have used an Ideal compiler to convert your Ideal interface to your target language. So method implementations of Ideal interface. I told you in Ideal you can only declare, you cannot define. So where do I want to define these methods, or the functionality of Ideal is where the functionality of Ideal is actually present. You can declare methods and variables in Ideal. Then you can define those variables and methods in other classes. These classes may be based on the target language. It may be based on C++ or it may be based on, Java. That is always depends on the target language. So method implementation are created in the implementation language you choose. In this case, we have Java. After you have used ideal, compiler to convert your ideal interface to your target language. So ideal, like C++, includes non-class data structure definitions like structs, union, and enumerations. There are some concepts in C++ called structures, structs, unions, and enumerations. So these, things you can also include in ideal as well. And method parameters in ideal include modifiers that specify whether they are input, output, or input-output variable. So one of the major difference in ideal method parameters is like you can declare as input parameter or output parameter or in-out parameters, right? So this is the major difference. So one is declaration. Second is name of the interfaces, methods, and data members. Third is method implementation. Fourth is regarding, certain non-class data structures like structs, union, and enumeration. And the last one is method parameters, the type of method parameters. In Java, we have only, certain kinds of parameters like integer, character, string, etc. But in case of ideal, we have in parameter and out parameter, input parameter and output parameter, also in out parameters. Right. So in Java, all primitive data types are passed by value and all objects data types are passed by reference. It's not like in ideal. Java, all primitive data types are passed by value. You know what is the difference between pass by value and pass by reference? All primitive data types are passed by value and all object data types are passed by reference. So these are the major difference between ideal and Java. Any doubts?